Okay, I have a very cool card effect to show you today. As you can see, I have a good selection of card values, suits, and colors. I believe there are 24 cards altogether. Okay. Now, since the two of us saw the cards, why don't we go ahead and just give it a Charlier shuffle. In fact, you can tell me when to stop doing a Charlier shuffle. Stop there. Okay, very good. Now what I need you to do is I'm going to thumb riffle like this down the side, and I need you to tell me when to stop, okay? And then we'll cut the packet in two according to where you tell me to stop, okay? So I'll begin. Stop there. Are you sure? A little further? Okay, that's fine. Set those down. Now I need you to choose either pile and we'll flip it face up. Left or right? Right one? Okay. Very good. And now we're going to rosette shuffle these two packets together. Quite the mess here. Very good. Okay, we'll square those up. Now at this point I'm going to deal out the cards into 4 piles. Look like the top maybe didn't get quite as well mixed as the bottom, but that's okay. Okay, very good. Let's kind of square these up here like that. Okay, now for these two here, I need you to choose one to flip over, left, okay, and how would you like these two stacked? Right on left or right on left? Okay, very good. What about over here? Which would you like flipped over? The right, okay. Whoa, that's kind of cool. And how would you like these stacked? Left on right. Okay, very good. Your choice. Let's bring these down here. Oh, let's not go off the camera view. Keep an eye on the camera. Okay, I'll just adjust those. And now what I'd like to do is I'd like to mix these with input from you, but mix them in very different ways. So the first mixing for this first little pile, I'll perform an even up jog. So this is where you jog forward the even position cards with random stacking decided by you. Do you want left on right or right on left? Left on right? Okay, very good. Set it down here. How about for this one? We'll deal into 2 piles. How would you like these piles stacked? Your choice. Right on left? Okay, very good. Let's go back to this other one to keep these lined up there. Why don't we do 3 piles? Would you like these stacked from left to right or right to left? Left to right? Okay, your choice. Very good. And then for this, why don't we do 4? Kind of fun to do 4. We have none 4 yet. Okay, and how would you like these stacked? Left to right or right to left, or even leapfrog stacking? I can show you that if you're interested. You want to do one of each, a leapfrog and non. Okay, that's fine. So for the non-leapfrog, do you want to go from left to right or right to left? Right to left? Okay, that's fine. Very good. Right to left. And then you wanted to see a leapfrog, which is kind of fun. Okay, so would you like to do the leapfrog stacking from left to right or right to left? Left to right? Okay, so this is how it works. This pile leaps over its neighbor, lands there. This one leaps over its neighbor, lands there. How would you like these stacked? Right on left? Okay, very, very good. Well, I think you would have to agree that these cards are beyond the knowledge of anyone. Okay, even though we saw the cards at the beginning, especially with that mixing I did using the Charlier shuffle, and you decided when I should stop doing that. Okay, and then you made all these other decisions in terms of stacking order. And all of those affect very much the ordering of both of these packets. And then we even treated these 2 packets quite differently in the mixing. Okay, so here all I'm going to do is I'm going to Klondike shuffle. It's kind of a fun shuffle. Klondike shuffle pairs to the table. Let me move this down a little bit like that. Okay, so there we have 6 pairs. Of course, that makes sense, I guess. And then we'll Klondike shuffle another 6 pairs. I'll apologize for going off a little bit. I need to do a better job at maximizing my screen real estate here, so I apologize for that. Okay, well, off to the side here, I've had a written prediction in camera view the whole time. So let's just take a look at what my prediction was for the outcome of all of these random choices and processes for which you had tremendous influence. Okay, so what is the prediction? Okay, so the 12 pairs of cards will each consist of a prime value card and a composite value card. What's a composite? Oh, a non-prime. There we go. So a non-prime. So each pair will have a prime value card and a non-prime. What do you think the chances are that that's the case? Okay, well, we count a queen as a 12. Okay, so that's not prime. So we're looking for a prime number. Oh, we got one. Okay, we got a 7 and a queen. That's a prime and non-prime. Here's another queen. Oh, let's see, 2. 2 is prime. Its only divisors are 1 and itself, so that's a prime. See, Jack. Jack's a prime, right? And 8 is not. Okay. Oh, man. Okay, this is a composite or non-prime. We want a prime. Yes, we got it. A king is a 13. That's prime. Oh, there's a prime. We want a non-prime. Yes, indeed. Okay, we got a non-prime. We want a prime. Oh, we got it. Okay, well, prime right here. We want a non. Oh, 4 is not a prime number. And 3 is, but 8 isn't. See, Jack's 11, prime. 9 does not. Okay. See, 5's prime. We want a non-prime. We got one. Oh, there we can see. Yes, indeed. 5 is prime. 10 is non-prime. We got a prime. And we're hoping this is a non-prime. Yes, it is. It isn't. 2 and 3 divide into 6. How in heaven's name did you do that? Making the choices, apparently the perfect series of choices that you just happened to make. You must have unbelievable intuition. Whoa, that is amazing. Okay, so how does this work? Okay, so what we'll do is, as before with other videos, we're going to use more of a transparent packet structure so that you can better see really what's going on here. Okay, so here we go. So I'll use reds. So don't worry about the card values now. We're just looking at colors. Okay, reds versus blacks. Okay, now, and this is all setup. There's not much to do for the setup, but this is setup. So for example, these, for me, before I began the performance, these would all be like prime value cards. And these would be non-prime value cards of different colors. You know, you have some red and black of each, right, to kind of mix them up. But we'll go with red and black so that we can see what's going on. So this is really the kind of thing I did. I just stacked these randomly, these blocks here, okay? Now we want these 2 blocks of red and black cards in an alternating relationship, okay? So a really slick way to achieve that is to perform a Klondike shuffle. Okay, so this puts the top and bottom half in an alternating relationship. So that's what that does. And I can even show you that, and it'll be easier to see here because we're just focused on color, right? So you can kind of see that it alternates in color, which is what we need. Our original packet alternated prime, non-prime, prime, and non-prime, and so forth. Okay, so this is really where I began with the cards that I showed you, right? Where it alternated prime or non-prime, okay? And then I said, well, since we saw the cards, why don't we go ahead and just give it a Chardelier shuffle until you tell me to stop? Well, a Chardelier shuffle is equivalent to just cutting the cards at some location. And the fact is, the original packet was cyclic, okay? So it's a cyclic construction, and it won't be hurt by packet cuts or anything equivalent to a packet cut. And a Chardelier shuffle, believe it or not, is actually equivalent to just cutting the cards at some location. So I will add a link in the description below to the Chardelier shuffle because that is a must-learn shuffle in mathematical card magic, okay? So it's still cyclic. We haven't heard it. Now, do you remember what I did next? I kind of thumb riffled down until you said stop, okay? And it is true, you could stop anywhere. Wherever the spectator tells you to stop, you can stop there. Now, aesthetically, it's kind of nice to cut about half the cards. And I'm not sure how well I did that, but cut about half, but you don't have to, okay? So think about it. We had a cyclic packet, okay? Now there's a famous principle, and I should include a link in the description below for this as well. The Gilbreth principle, a powerful principle from Norman Gilbreth, a mathematician engineer who discovered this principle in the mid-1950s, believe it or not. And it's been used ever since in just amazing and mind-blowing ways. Okay, so the Gilbreth principle says if you have a cyclic construction and you reverse count any number of cards to the table, because that switches the order of the cards when you deal to the table, and then you like riffle shuffle those, you know, kind of how you do a normal riffle shuffle. This rosette shuffle that we'll use is mathematically equivalent to a riffle shuffle. If you do that, certain properties are preserved. In particular, if we were to do that here, in fact, let's back up here just for a second. So before I did the thumb riffle, okay, so if I were to deal any number of cards to the table and then bring those together by way of like a riffle shuffle, what will happen is each pair of cards from the top will consist of a red and a black, okay, as you go all the way down the packet. Well, in our original performance, it would be that each pair of cards consists of a prime value card and a non-prime. Okay, so just kind of hold on to that idea. Now, instead of reverse counting, so here we haven't changed the order of the cards, I just broke off a block. Another way to reverse the order of a packet of cards is to just flip them over. Now they're in the reverse order to what they were. And it is true that you can have the spectator flip either half, not both, but just one of the halves. Now at this point, if we perform a rosette shuffle, this will be mathematically equivalent with the flipping over of one of those piles. This will be a Gilbreth shuffle, they call it. And so because of that, the Gilbreth principle applies. So let me just show you that really fast here. So for example, see, this is red. This one here would have to be black, okay? Let me move this one over. These two, the next two, would have to be a black and a red, and they are, and so forth. Black, red, or red, black, and so forth, okay? So that's the Gilbreth principle. In the original performance, it would have been like prime, non-prime, okay? So that's really kind of where we are right now. We've used that powerful principle called the Gilbreth principle. Okay, now what's new to the world of card magic, period? Okay, and I introduced it on my channel. I don't believe this is known anywhere, okay? I've found nowhere where this is talked about or discussed. If we now deal this into two piles, left, right, left, right, left, right, what we will be doing is we'll be creating what are called coupled piles. Coupled piles are piles where at each level the two cards are related, okay? Now the relationship here will be that those two cards will consist of a prime and a non-prime, okay? So each pair, so at each level, as you go down, you'll get a prime and a non-prime in some order, but it doesn't matter. So you'll never get like two primes together or two non-primes, okay? Same thing here with the reds and blacks, okay? So that's dealing out into two piles. Well, what I did was I dealt out, so we dealt out into two piles there, okay? So these are guaranteed to, here it's opposite color, right? And then I dealt out into two more pairs. So let me just show you what this will mean is these will now be related by way of a post-Gilbreth shuffle. Namely, these will be of opposite color, okay? So you just go through. So each pair is being separated in the top row and the bottom row, okay? Like this. Hopefully I didn't stop shuffling. That I finished the dealing there. Okay. So technically, in the language of the principles taught on the Absolute Math Magic channel, these are coupled piles, These are coupled piles. What does that mean? In this case, they'll be of opposite color as you go all the way down the packet. Or in the original performance, there'll be a prime and non-prime as you go all the way down in the packets. Okay? So if we randomly stack these, we get a two-cycle structure. It's a cyclic construction. Okay? That's something taught on my channel, and I'll provide links in the description below. But that's not quite what we did. I allowed you to flip either half. Okay? Now what that will do, if we now stack these, instead of being a two-cycle or a cyclic construction, it will be mirrored. Okay, and so that's also talked about on my channel. So we can randomly stack these. You can flip either one, maybe this one. Randomly stack, maybe they want left on right. Okay, so these are now mirrored packets. Let me just kind of show you that that's the case. Okay, that's kind of important to know that. So I'll just show you. So mirrored means as you look at the outer cards and then come in 1, 2, all the way to the center, the cards will be related in the way that you want. So for example, the relationship for this tutorial portion is that the cards be of opposite color. So the black ace, red 7. Okay, what about the second one? We get a black 2. This better be a red something. It's a red 3. So as we come in, let me just go pairs here. Yeah, that's okay. I was just making sure I count right. So the very two middle cards will be those, and they're of opposite color. Okay. So in the case of the performance, there would be one prime and a non-prime in that pair. Okay. And so quickly the same thing here. So this better be black, right? Because it's in a mirrored relationship with that red ace. Okay. So the fact is these are mirrored packets now. And so now we can use the traditional, not the new one, but the traditional stay stack principle that's been around for quite some time. Well, what does that say? Well, that says if you have a mirrored packet, for each divisor of the packet size, you can deal out the cards into that many piles with random stacking from left to right, right to left, or sometimes you can do this leapfrog stacking in the case of an even number of piles being dealt, which I used. Okay, so what did I do? And also, I guess I should point out, not only does this dealing out into a number of piles, where that number of piles divides 12, this is the packet size now, 12 for each of these. By the way, the divisors are 2, 3, 4, and 6. You can also do other mixing that will preserve the mirrored structure here. Okay, so one is a even or odd up jog, and that's what I did. Yeah, that was the first one I did. I did an even up jog, okay, like this. You strip those out, random stack. Okay, this is still mirrored. Let me just try to convince you of that a little bit. So this one's red, this one here better be black, and it is. Okay, so that's what I did for the one on the left. Okay, the one on the right, do you remember what I did? I just did a left right. Well, I'm dealing into two piles, and 2 is a divisor of 12. So by the stay stack principle, if we randomly stack these, this will still be, quote, mirrored. Let me just show you that. So we have a black 2, and this will be red right there, red 3, and so forth. Okay. Well, we did some more mixing, because then I picked up this one. Oh, I dropped it. Then I picked up this one, and I dealt out into 3 piles. Well, why can we do that? It's because 3 divides into 12 evenly, okay? With random stacking from left to right or right to left, that really is the case. Do you remember what I did here? I dealt out into 4 piles. Well, 4 divides evenly into 12 as well, so it's a divisor. Now here, there's quite a bit of stacking options. You can stack from left to right or right to left, or you can do this leapfrog stacking that I've introduced. I've never seen anyone do it before. I showed it on my channel. So here, like leapfrog from right to left, this one leaps over its neighbor lands there. This one leaps over its neighbor lands there. Random stack here. It truly is random stack there. Okay, so I believe that's all of the mixing that I've done. In the performance. Okay, move that up. And then to finish, do you remember what I did? I did a Klondike dealing of pairs to the table. Well, think about what is that going to do? if this one, let's just show you here. If this one and this one are related, it's a mirrored packet, which it is. If this one and this one are related by way of being of opposite color, which is what we set up, then of course this will be black. You can show it, black queen. Well, what's going to happen if I Klondike shuffle? It pulls the top and bottom cards off as one, right? So those will be paired up. The king here will be paired up with whatever second, which is black, and so forth, okay? So what you'll be doing is you'll just be putting out pairs of cards that have the very connection to each other that you want. You want these pairs to each consist of a black card and a red card, okay? And that's going to be true for this too, because the bottom card, well, I guess it's technically top card, and the bottom card opposite color. So as you pull those off, those will be of opposite color. Now in the original performance, of course, we're going to run out of room here. Instead of opposite color, it would be prime, non-prime, right? Okay, there we go, opposite color. Okay, and then you just bring out your prediction and watch your spectator's head explode with surprise. Like, how in the world did they just happen to make this perfect selection of stacking and so forth along the way that would lead to this outcome? Okay, so anyway, that's giving a quick overview as to kind of what's going on here. If you want to learn more about the Charlier Shuffle, the Gilbreth Principle, or the Stay Stack Principle, I'll add links in the description below to all of those. Okay, so you can learn those a little bit better. Okay. So anyway, so thank you for watching, and this will work for you every time if you just follow the principles that I've shared with you today. So take a look at other videos on the Absolute Math Magic channel.